As you can see, I'm travelling along in the utmost style and comfort and at 125 miles per hour. It's really extraordinary when you think that it wasn't all that long ago that there weren't any railways at all and everyone had to travel places by horse and carriage. But since those early days of the railways, quite a lot of very interesting and exciting things have gone on behind the scenes. So let's take a look at the railways today and see what I mean. For instance, you can't go very far on a train without wheels. So let's look at the wheels. Now here's a brand new wheel being lifted out of boiling oil at Crewe Engineering Works. If it doesn't go on first time, the engineers have to start all over again. But that's a perfect fit. Here you can see lines of powerful electric engines being built. It takes a lot of skill to design and fashion the hundreds of intricate parts which fit together to make these huge engines. Soon the wires will carry electricity to drive the trains. This is the Pantograph. It draws power from the wires and passes it on to the electric motors which drive the engines. Once the wires have been put up, engineers must check every section because continuous contact is essential if the locomotives are to work properly. Because a great force of electrical energy, 25,000 volts in fact, passes through the contact point, which, believe it or not, is no bigger in size than the end of my thumb. It's also important to remember to keep a very long way away from these wires because the charge itself can jump quite a distance. This is one of the railway's newest electronic signal boxes. What it does, in effect, is guide the trains and keep them on the move over great distances. Here's one being wired. Quite a tricky job connecting up all these spaghetti-like wires. You have to make sure that each one, and there are many thousands of them, connects the finger-touch controls on the operating panel correctly with the trackside points and the signals. You can watch the progress of each train on the control panel. Now, with so many trains running about, it's quite obvious that the rails get worn and have to be replaced from time to time. This machine is bringing in new concrete sleepers. Now a trainload of ballast is emptied onto the track. These rails are about half a mile long, and this machine, whilst pulling up the old ones, is laying in the new. Here's a machine that concentrates on pulling newly laid track into its correct position. Just look at those sleepers sliding sideways. Here's another one which can line up the track accurately and make it level by forcing stones under the sleepers. Just as the blood pulsing through our veins gives life and energy to our limbs, so too the railways of Britain spread out across the countryside, drawing communities closer to each other. Most of all, though, they get us where we want to be. It might be you going to school or people like me getting to work. Did you know that every morning at least 250,000 people arrive at London stations all in the space of just 1 hour? Well, imagine what that would be like with time speeded up. This is London's Waterloo Station. As you can imagine, it's quite a problem for the station manager and his staff with all these people arriving at the same time. Every day, tides of people arrive in the morning and go home at night in every major city. The railways don't only carry passengers, but a good deal of freight as well. I'm at the Willesden Freightliner terminal in northwest London, where goods are carried in containers. This one here, for instance, could be carrying anything from chocolate biscuits to television sets, or even the latest fashion dresses. And I bet you don't know what's in this container that's dropping in beside me now. Mind, I shouldn't worry too much about it, because I don't know either. But the railways do carry all sorts of goods, and use different kinds of wagons, and I think you'd be quite surprised at what some of them contain. I mean, it could be building materials from a quarry. Iron ore. Hot chocolate. Or even molten iron. This needs very special attention because it has to be moved at 1400 degrees centigrade. The huge container had to be designed to keep the temperature up, otherwise it would become solid, and that wouldn't help at all. At the end of the journey, the metal is still molten and produces quite a firework display as it's poured out of the huge container. There are also liquids like oil and gases like nitrogen, and thousands of tons of other chemicals are regularly sent by rail too. Because of the tremendous weight of most freight trains, the drivers have to be particularly skillful. Let's hear from a driver.
I'm approaching Chelliston Junction, where the line that I'm going to travel on is around a very sharp curve. To make matters difficult, there's a dip in the line, a steep gradient in, a steep gradient out. I've 900 tons behind me, and there's a speed restriction of 20 miles an hour around the whole of the curve. I'm going down the first gradient into the dip, taking care not to exceed 20 miles an hour. I'm almost in the dip. I'm increasing power to keep the train stretched out. The line rises pretty sharply now. I'm increasing power, careful to keep it at the speed at 20 miles an hour. If I have an indicator light that tells me wheel slip's taking place, I'm correcting it. I'm going to ease power, I'm easing power, back to normal, the road level's out, I'm back to normal running, everything's okay.
Sometimes trains have very unusual jobs to do. This one, for example, actually links up two motor car production lines in different countries. The containers are carrying parts of new cars from the factory in Liverpool to be assembled in the factory across the sea in Belgium. The ship's captain, like the train driver, has to keep a watchful eye on his cargo as well as his ship. Perhaps you didn't know this, but British Rail run ships and hovercraft as well as trains. There are a lot of ships in the North Sea, but it's even busier at Dover. You can actually skim across the channel just above the waves in this hovercraft, travelling at 50 or 60 knots on a cushion of air. If you're wondering what this has to do with railways, well, this is the famous Roundhouse in London, where all sorts of entertainment takes place. But once upon a time, inside this huge round building, engines used to be cleaned and prepared, ready for their journeys to the north. Engines like these. The railways in Britain are over 150 years old, and now many of these lovely old steam engines are preserved for all to see. They didn't move quite so fast as today's engines, but they were a grand sight all the same. And you can still see some of them at the Railway Museum in York. And how's this for a contrast? The experimental version of British Rail's latest train, the Advanced Passenger Train. With experiments over, more of these are being built and will be running soon. And I, for one, am looking forward to travelling on them. This mainline electric locomotive weighs 80 tons. With all its coaches behind it, the whole train can weigh over 500 tons. And even with that tremendous weight, it's still possible to reach speeds of 100 miles per hour. But as I'm sure you can imagine, to stop safely from that speed can take up to 2 miles. Well, that's it. The end of a brief glimpse behind the scenes. But there's a whole lot that we haven't seen. Nowadays, new railways are being built all over the world. Through jungles, through swamps, even over mountains. We in Britain are using our experience to help build many of these railways. Perhaps one day, some of you may be helping too.